the mass driver is still in the conceptual or proposal stage. So why does Elon Musk want to build one on the moon? His plan is to launch satellites from it, and there is some merit to this idea. First off, because the moon is so much smaller than the Earth and 1/6 the gravity, its escape velocity is only about 1/5 of Earth. It also has no atmosphere, so no wind resistance to slow down or knock it off course. This means a mass driver on the moon doesn't have to be as long as one would need to be on Earth, somewhere around the 100-kilometer mark for human travel, and a lot less, possibly even 1 kilometer for objects like satellites, depending on if the materials could stand up to the forces. A mass driver would also lessen the moon's dependency on importing chemical rocket fuel from the Earth, potentially even relaunching spaceships back to Earth as well. It can be powered with solar energy instead, which the moon receives an abundance of. According to Musk, thanks to advancements like in space propellant transfer, SpaceX's Starship will be capable of landing massive amounts of cargo on the moon. Once there, it would be possible to establish a permanent presence for scientific and manufacturing pursuits. How many solar panels would you need though? It's estimated that a mass driver of this size would need 10 to 20 megawatts of continuous power to operate, about the same as a small town. Due to the increased efficiency of the more direct sun and no atmosphere and cloud coverage to factor in, it's estimated that solar panels could generate somewhere in the region of 400 watts per meter on the moon, versus the 150 to 250 watts on Earth. To generate enough power for the mass driver, it would need to roughly cover 50,000 square meters, and then you would have to factor in the lunar nights, which last roughly 14 days. So depending on how frequently the device is used, over double the solar panels could possibly be needed with battery-based energy storage. However, somewhere around the 100 kilometers square or 62.14 miles squared is not a vast distance to cover by Earth standards, with the largest solar park on Earth spanning 609 kilometers squared.